start studying the process of combustion. You know, what makes things burn? What is it? What exactly is to burn? What is that phenomenon? Because, well, clearly you burn something and something that had one form now has the form of ashes. You examine the ashes and the chemical composition of the ashes is now different from what it used to be the original stuff like before burning. So there's transformations. There's something going on there. And there was a huge controversy, an international controversy, over which of the two theories, that of Lavoisier, of that of Priestley, explained combustion. Lavoisier said that it was a certain substance acting as fuel, which he called oxygen. Priestley said that it was not. It was an essence or principle of combustibility that he called phlogiston. It is the principle of combustibility. You know, when things burn, they are not getting oxygen from the air to burn things. They are actually expelling phlogiston into the air. And so what you really need to start combustion is to fill the chamber with dephlogisticated air. Right? Now today it's very easy to laugh about it because we know that phlogiston is a totally bogus entity. It simply doesn't exist. But at the time, there was no way of knowing. At the time, we didn't really know that there's an atomic structure for oxygen. We didn't know that there was a table of the elements where oxygen is right next to carbon and nitrogen and everything fits just perfectly. We didn't know that water is one atom of oxygen plus two of hydrogen, or carbon dioxide is a combination of oxygen and carbon. So we didn't know any of that. So the two had an equal chance. There was not in any way, it was not unreasonable for Priestley to stick to his phlogiston theory for as long as he stuck to it. But the controversy, when you actually read what they wrote about each other, it's a catfight. I mean, the two guys couldn't be less gentlemanly about it. I mean, you would think that, the internationality of science, that we are an international community, an international brotherhood, and we represent the light of reason, right? When you actually read what those two guys wrote about each other, you go, Jesus Christ, this is like a Hollywood fight between Jennifer Lopez and someone else. I mean, I can't even think of Madonna or something, right? I mean, they're talking about each other like they're a bunch of idiots, and you go, wow, this can't be the kind of science that they taught me in textbooks, because this is really, creepy personal attacks, right? And not only that, predictably, all the French sided with Lavoisier and all the English sided with Priestley, at least at the beginning of the controversy, which again, it proved that the myth of the internationality or cosmopolitan character of the scientific brotherhood was a myth, since you were siding with one scientist or another depending on your nationality. So the science studies people, the Bruno Latours of the world, focus on those controversies, because it's on those controversies that the seamy side of science, the sleazy side of science, immediately comes across. It just shines right through, and correctly identify the inappropriate nature of those fights, but incorrectly assert that it was the winner of the social controversy, the guy who managed to get more allies, the guy who simply managed to win by power, that established his entity, oxygen versus phlogiston, as the reality of the thing. But in fact, there's no reality of the thing. If you ask Bruno Latour right now, and I wish he was here so that you would believe me, if Priestley had won the controversy, would an entire different chemistry developed that was in terms of phlogiston and dephlogisticated air and other new airs that were to be discovered, and the periodic table of the elements, and the idea that water is H2O, and the idea that scuba divers can bring tanks with oxygen and breathe, and all of that would be totally wrong. And they would say yes. They would actually say yes. Until you actually ask them to specify, well, can you exercise your imagination and give us a scenario? What would have been that possible history of all the possible history of chemistry that would have triumphed just as chemistry did, but entirely with essences of combustibility? And of course they can't tell you that because they don't even bother to learn about the details enough to do it. They just simply focus on the controversy, see how definitely social it was in the sense of not having anything to do with a rational argument of one person convincing another with arguments, but kind of like cat fight, and say, look, those cat fights are very, typical of any scientific controversy, which shows you that science is not producing objective knowledge, it's simply producing the knowledge of the winners of the controversies. Had there been other winners, there would be an entirely different scientific body of knowledge. Now the way to fight that, and this is the last thing I want to say about these people, is to show them how what they're doing is wrong methodologically. You accept the fact that Priestley and Lavoisier were two prestige-driven and ambitious persons who wanted to win because they wanted the fame themselves. You're not going to bring here a super rational man who shines the light of reason on things. That doesn't even exist. But rather, extend your scale of observation. We've talked about this several times yesterday, about how different entities become or change at different speeds. So change your time scales from the 5-year time scale of the actual cat fight to 50 years. 25 years before the cat fight, 25 years after the cat fight. And include not only the two protagonists of the cat fight, but the 15 or 20, some Italian, some Dutch, some German, some British, some French scientists who were all participating, not just like the two major contenders that were like insulting each other, but also the other ones, the ones that never even participated in the cat fight and were simply trying to follow what's going on in the controversy. When you extend your space, your temporal vision to 50 years and your spatial scale to include all of Europe, with all of the different scientists, even of minor countries, but that were still contributing to that, you see an entirely different picture. What you see is 12, 15, 20 scientists, collectively, neither one of which, by the way, has a complete knowledge of the field, so neither one of which can shine the light of reason into things. They knew a certain amount of facts, and they were specialists in a certain amount of laboratory experiments and theories, and their fields of expertise overlapped, but no one had a complete vision so that in his own mind the truth could have emerged. And what you see is more of what happens in an anthill, or in a colony of termites, or in a beehive, in which a collectivity unconsciously produces something, or semi-consciously, if you want to put it that way, just like the hexagonal forms of a beehive's compartments, simply by interacting with one another. What you see here basically is those 20 scientists were exploring a space of possibilities, of all the possibilities that could account for combustion, and were little by little finding dead ends and then marking them as a dead end, then collectively moving to another area. Well, maybe it's a kind of phlogiston, but then finding that as a dead end, and then over the 50-year period, discovering that the real only exit, the real true exit, was oxygen. That's the first 25 years. The next 25 years you also need to include them, because that's when oxygen begins. It's not only oxygen, it's to begin to discover all the different chemical elements, and they all begin to fit beautifully in a table of the elements that really captures the rhythms of the life of chemical species, because it has a very specific rhythm in which properties repeat themselves in a beautiful way. So beautiful, indeed, in terms of its symmetry and its way of revealing the properties of different elements, that the guy who drew the final form of that table, there were many, as usual, there was 10 or 20 different guys trying to get that right, but the one whose name was eventually attached to the table, Mendeleev, had the guts to say, look, this is the